Hi viewers, because the torque of the Tyroden lock nuts on a Jeep Patriot has to be set to 97 foot-pounds, I decided to bench test some of them to demonstrate a possible risk of stripping the threads.
Recently I had to replace both Tyrodens on my vehicle, and I wanted to compare a good quality part I got from my local auto parts store with a low-cost part I ordered online. I began the project by replacing the Tyroden on the left-hand side. At first sight, the new product was similar to the one that was previously installed. This model had a long ball stud like the original Jeep Mopar replacement. Nevertheless, I noticed that the nylock nut had a lower profile than the old one. I was concerned by the fact that there was probably a smaller length of engagement. However, I adjusted the torque wrench to factory specification, which was 97 foot-pounds. But when I was tightening and reaching around 80 foot-pounds of torque, I felt a loss of tensile strength. I was a little worried about damaging the threads, but I slowly continued tightening the nut and finally I was able to reach 97 foot-pounds. I was satisfied with this model of Tyroden, but I would have preferred to use a nut with at least one more thread. During the following week, I received the low-cost Tyroden I ordered online. My vehicle was already in the garage and it was time to replace the part on the right-hand side. Later, when I was ready to loosen the jam nut, I had to heat up the part to be able to remove it, but so far it had been an easy replacement. The old part on the right-hand side had a different design from the one on the left-hand side. It was held with a castle nut and secured with a cotter pin. It was also a good quality part I installed 5 years ago. When I compared the parts side by side, the new Tyroden had a smaller ball stud housing and some other dimensions were different. What concerned me the most when I was comparing the assemblies was the small castle nut included in the kit. This new low-profile castle nut had a length of engagement with only 3 effective threads to withstand 97 foot-pounds of torque. With so few effective threads, I was quite sure there was a risk of stripping the nut. To evaluate the tightening limits of the axial load strength of my castle nuts, I used these selections of parts. On the left, the big nylock nut had a length of engagement with 8 threads. I named it 8X. In the middle, the 3 spare castle nuts had a length of engagement with 4 threads. I named them 4X. Finally, on the right side, the 3 new castle nuts had a length of engagement with only 3 threads. I named them 3X. To validate my results, I used 2 common models of Tyrodens that I kept for metal recycling. Later, when the parts were removed, I cleaned the threads to make sure they would perform the same way with all the nuts. To hold them during the test, I made 2 flat surfaces on each of them. I also used a common hexagon nut to check the integrity of the threads on the ball studs after each test. I began the overall evaluation with the tests number 1 and number 2. I tested the nylock nut 8X with each of the 2 studs and I had no problem to apply 97 foot-pounds of torque. After that, I continued with the tests number 3 and number 4. For those ones, I used the castle nuts 4X. Again, the nuts were tightened and the torque was set to company specifications without problem. To make the tests number 5 and number 6, I used the low-profile castle nuts 3X. But when I was applying over 80 foot-pounds of torque, I could feel it was deforming the threads. Finally, I was able to set the torque to 97 foot-pounds. Nevertheless, it was obvious that the threads were damaged because when I removed the castle nuts, it was difficult to unscrew them. Also, because I was curious to see the possible consequences of tightening the castle nuts 3X with lubricated threads, I added the test number 7 and number 8. The thread failed when the level of torque was close to 97 foot-pounds. But during the test number 8, it was even worse. The thread failed when the level was reaching only 65 foot-pounds. In this view, you can see a castle nut 3X with the effective threads severely damaged. The studs S1 and S2 were also damaged during the two last tests. With the assumption that the torque specification provided by the manufacturer is exact, I think the main reason why the castle nuts and the studs were damaged was simply due to the inadequate selection of the castle nut included in my low-cost Tyroden kit. After these results, I was very confident about completing the torque procedure with a better castle nut I had kept in stock. Obviously, I used a spare one made with a minimum of 4 effective threads. I didn't use any lubricant in order to properly tighten the castle nut. It was set to 97 foot-pounds and I didn't worry about the reliability of this castle nut. Another problem with my low-cost Tyroden was the dimensions. They were not exactly the same as the old one. Because of that, I could not trust my toe-in adjustment, so I decided to perform a new wheel alignment. I kept the jam nut loose to be able to adjust the toe-in to company specifications. Later, when the vehicle was jacked up again, I tightened the jam nut and the torque was set to 55 foot-pounds.
The different tests I made confirmed that whether I have a nylock nut or a castle nut provided with the new Tyroden, I will replace it with a better one if there is any apparent risk of stripping the threads.